Example 1 on lesson 52, a druggist has one solution that's 10% iodine and another that's 50% iodine. How much of each should the druggist use to get 100 milliliters of a mixture that's 20% iodine? So this happens quite often in pharmacies. They'll have specific percentages of medicine, but they'll be asked to give something they don't have. All right? As long as they have something that's too weak and something else that's too strong, they can make something in between, any percentage in between. So you have a 10 and a 50, you can make a 12 or a 33 or 50 or 49, those will all be possible. I couldn't make a 70 out of a 10 and a 50. Okay, because I need something too strong, something too weak, something on either side of the one I want to get. So first thing I want to focus on is the percents, and they have to deal with the same substance. And we're going to be mixing two to make a third. All right? So what we're going to try and do here is we're going to be mixing the weak and the strong to get something in between. So what I've got here is something plus something equals something. The things that are being mixed go on this side. The thing that we're making goes on this side. And the percents go on top. So 10% is being mixed with 50%. And our overall goal is to get a 20%. So that's priority one. Get your percentages dealt with. And again, focus on what's being mixed together and what you're trying to make. And what we're doing today, everyone's going to be too weak and too strong, add to make the middle. Something in the middle. All right. Then, I need to start putting amounts in. I always start with the one that I know. All right. We're getting 100 milliliters of 20%. So 100 milliliters goes here. And it very clearly states how much of each, which means I don't know either of these, right? Okay. Here's the trick to these problems. I can't have more than one variable. I've got two things I don't know. I only want one variable to represent the two things I don't know. So I don't know either one of these things. I'm going to call one of them x. It doesn't matter which one I call x. I need that to be a true equation. I need the left side, this thing plus this thing, to equal this thing. All right? This has to be 100 minus x to make that happen. Let me demonstrate why. If I add x to 100 minus x, what happens to the x's? And if the x's cancel, what's left? See? All right? So it's very simple. But again, in each of the problems you're going to get today, you're not going to know either one of these things. They're going to give you the final amount every time. One of them is x, the other is whatever this number is minus x. In that order specifically. It will never, not even one time ever, be x minus 100. It will never be that. Not even once. Please don't write x minus 100. Don't write that. Write 100 minus x. If this was 600, 600 minus x. 23, 23 minus x. Hippopotamus, hippopotamus minus x. Doesn't matter what this is, that number minus x goes there. Okay? I don't know what causes your stress. What causes my stress? People doing things backwards. So anyway, trying to prevent that. So, once you get all these boxes filled in, this is a graphic organizer that really helps you set up the problem. This product plus this product equals this product. Okay. And I know they all say percent, just treat them as whole numbers. I can go 0.1 times x and 0.5 times 100 minus x and 0.2 times 100. That would also give me a true equation, but this equation is easier to work, no decimals. They both work, so let's go with them with no decimals. And what's left to do is to solve the equation. Distributive properties required here. So I'm going to get 10x plus 5,000 minus 50x equals 2,000. Move the 5,000 over to get the x's isolated on the left. 10x minus 50x is negative 40x. 2,000 minus 5,000 is negative 3,000. So to get x, I simply have to divide negative 3,000 by negative 40. Comes out to 75. as with most graphic organizers, they do two things. Number one, they organize everything to create a nice equation for us. The other thing they do is they allow us to interpret our answers to see what our answer represents. If I go back to this graphic organizer, I find X, I look and see what X represents. It's 10% iodine, right? So 75 milliliters of 10% iodine. And the other one would be what? 25. We know that the two substances have to add up to 100, right? So if this one's 75, 100 minus 75 equals 25. So we get 25 milliliters of 50% iodine. There we go. That's just terrible writing. 50%. There we go. Not any better, but okay. So if you're the druggist, pharmacist, whatever, and you have to make up this 20% iodine solution because that's what the doctor ordered for you, and you get your stuff, you get your beaker here that's empty, and you get your little, I guess, drop or whatever, like a syringe or something, and you suck out 75 milliliters of 10 and stick it in that one empty beaker, put 25%, 25 of the 50, and then shake it up. It's 20% iodine is what you're going to get. You're going to have exactly 100 milliliters of it. So that's what's going on here. And again, that's what we're trying to figure out. And this is how your answer should be written. Don't just tell me numbers. Tell me this much of that and this much of that. Specifically identify what each answer represents. Don't just give me 75 and 25. Because if you put them backwards, if you go 75 of 50 and 25 of 10, now you've got a 40% instead of 20%. Right, which then the person has too much iodine, and their cut gets healed more quickly or something. I don't know. We don't want them to heal too quickly. They kicked our dog, so we don't want them to heal too quickly. So, all right.